we have an iOS and SwiftUI app for real-time object detection, segmentation, and tracking in videos, combining latest Apple technologies. We can use the Codex app on macOS to create an app like this by combining the latest Apple technologies and APIs along with different AI models. So this app is using the recent Core AI framework that was released during WWDC 26. Using the Core AI framework, you can run different models entirely on device on Apple platforms like iOS, iPadOS, visionOS, and macOS. So when you find any model on Hugging Face and you want to use it to add intelligence to your SwiftUI app, you can convert it to Core AI model by using the Core AI PyTorch extensions. You can also use Codex to convert the Hugging Face models to Core AI compatible to use them in SwiftUI. There are also already made Core AI models you can find on GitHub. You will find them in the description of the video. So to create our object detection, segmentation, and tracking app in SwiftUI, I first added this Swift file to my project and asked Codex to implement it in SwiftUI to create an app that detects objects in the iOS device's camera, draws bounding boxes around them with labels using RF-DETR, consisting of these four models. RF-DETR is a real-time vision model from RoboFlow. You can use the model for object detection and segmentation in videos. You can find the model on Hugging Face. To use it in Core AI, you need to convert it using the Core AI PyTorch extensions. You will find a link in the description of the video. Over here, you have seen they have a quick example of how it works. The converted Core AI model for RF-DETR can also be found in this GitHub repo, Core AI Model Zoo. This guy has converted many of the Hugging Face models to Core AI compatible. So over here, we have the RF-DETR model. So I added this URL to the prompt in Codex and also specify in the prompt to use the RF-DETR model consisting of 4 different models: nano, small, medium, and large. So if I go back to the prompt in Codex, that is what I stated here, and also added a link to the Model Zoo repo. So we want to build the app using the Apple's Core AI framework announced during WWDC 26. The app should support Apple Intelligence foundation models and also using the Speech Analyzer API and its speech transcriber model for speech-to-text or dictation. I also specify how the UI should be. So we want to display the iOS device's camera in full screen mode and overlay a toolbar and tab bar buttons right on the camera feed. When we run the app, we want to use the RF-DETR model from the Hugging Face repo I just showed, that is Model Zoo, for object detection in real time. The app should also allow users to send a test prompt to ask questions about objects seen in the user's camera feed and also use their voice as input. And finally, we want to enhance the UI with liquid glass effect. So I added these 2 URLs for the Speech Analyzer API and its speech transcriber model to allow users to use their voice to send prompts within the app. So the demo is using 2 models, RF-DETR and also MetaSum-Tree. As you have noticed from the prompt, I didn't mention anything about MetaSum-Tree. That will come in a follow-up prompt. So I sent this prompt. Codex went ahead to plan and updated the Swift file to build the app using Core AI. So if I go to the SwiftUI project and go to the navigator, if I scroll down, under package dependencies, Codex modified the Xcode project to add all these dependencies for the Core AI implementation and also created the following Core AI files to configure the app to work seamlessly with Core AI. So let's go to the Xcode toolbar and run it to see how it works. You have noticed here my iPhone is selected, so I'll run it on my iPhone. So once you launch the app, you have noticed you can detect objects in real time. On the top left of the screen, we have the models. So we can select any of these RF-DETR models. Before you'll be able to use any of these models, you need to download them. So if I go to the tab bar and click models, you have seen we have all these models. I have already downloaded RF-DETR Nano and also RF-DETR Small. So to use medium or large, you need to click here. You have noticed the download is now in progress. So after the download is done, you can use it for real-time object detection in the app. I will go back to Codex and show you what I did next. After running the app for the first time, I added this follow-up prompt. I got an error about invalid configuration, so I asked Codex to fix it. So it went ahead to modify the RF-DETR model and also updated the implementation. Next, I wanted to add a MetaSum-tree model for real-time segmentation and object tracking in videos. So I added this follow-up prompt and pointed to this GitHub repo. This repo is the official CoAI models repo. If you visit this repo and go to models, we have different kinds of models like Gemma-tree, Mistral, Quen-tree, and more. Over here, we have the SUM-tree model. So I added the link to the SUM-tree model in the prompt. So Codex went ahead to do the implementation. So over here, you have noticed this is what was changed. It added a segment tab to the app by doing the implementation in Realtime Object Detection.swift and modify the CoAI package as well. If we go back to Xcode and run the app again, you have noticed we have a segment button to segment objects in the video. In order to do that, we first need to download the SUM-tree model. So I'll change the person to cap. So it is going to segment it shortly. It has now isolated the mark, but this is not accurate. So we can still go ahead and add a prompt to improve the segmentation. With the Ask tab, we can ask questions about the segmentation and object detection. So over here, we can add a test prompt or use a voice input by tapping the microphone icon. What do you see in the video? If I go back to Codex and scroll down further, I also added another follow-up prompt. One was related to the UI. Whenever the keyboard was active, there wasn't a way to dismiss it. So I wanted Codex to modify the implementation so that tapping anywhere on the screen will be able to dismiss the keyboard. The same issue was also happening with other overlays. Tapping anywhere on the screen should be able to dismiss the overlay. The segmentation mask was also remaining on the screen whenever you switch to different tabs. So after sending this prompt, it went ahead to modify the code. These were all the things that were changed. So once we run the app again, we can tap models on the tab bar to show the overlay and tap anywhere on the screen to dismiss it. And also tap ask. Over here, we can bring the keyboard, and once the keyboard is in focus, we can tap anywhere on the screen to dismiss it as well. There is one thing I forgot to show you in Codex. If I bring the left navigator, you should go to plugins and install the Build iOS app plugin. So this is the plugin you should install to get the latest Apple technologies, frameworks, and APIs. You have noticed here it has 9 different scales. So by installing the Build iOS apps plugin in Codex, you will be able to tap into the latest Apple technologies, APIs, and frameworks to add intelligence to your apps. In this example, I showed you how to tap into the new CoAI framework from Apple to bring AI models from different providers and run them entirely on device, on your Mac or iPhone.